Hi everyone, my name's Hemani and I'm a second-year graduate student in the geobiology program. Scientists think that one of the most promising places to find life in the solar system is Europa, a moon of Jupiter. And Europa is a really special place because one, it has liquid water, and two, it is one of 3 worlds in the solar system amongst hundreds where the ocean is in touch with the rock, the other 2 being Enceladus and Earth. And water-rock reactions are really critical to life on Earth. They produce a host of interesting chemistry, and water itself is great at dissolving and transporting nutrients. So if life exists on Europa, it's probably down in these hydrothermal vents or at the ocean-ice interface. And you could imagine it coming up through the ocean currents, through the ice, and the bacteria being deposited on the surface. Once that happens, they're hit by charged particle radiation, which is probably going to kill them, but that's okay. We can still work with that. I'm interested in studying how this radiation is going to chemically change the bacteria. And I do this by taking bacteria from real hydrothermal vents in Earth and putting them into ice mixtures. And then this mixture goes into this vacuum chamber you see on the right, which goes down to Europa's surface temperature and pressure, a cold 78 Kelvin. I then irradiate them with my electron gun. And after the end of the experiment, I have what the bacteria look like after years on the surface of Europa. Through these windows, I can take spectra, which produce unique peaks, as you can see down here, corresponding to organic molecules that are present in the mixture. So once I have all this data, there's a mission going out called Europa Clipper that's going to orbit the surface of Europa, and when we get data back from it in 2030, we can compare it to this library of spectra that I've been creating. And this data is critical to distinguish, one, if the organic molecules that we might find are actually coming from inside the ocean or just being deposited by impacts, because meteorites actually carry a whole host of organics. Two, if the organic molecules are actually made by life or not, because for example, the solar system can make certain amino acids entirely without the help of life. And 3, if the organic molecule is made by life, how long ago was it alive? So while it's a dream to have a very hot big nuke that melts through 20 kilometers of ice and reaches the ocean one day, that's pretty far off from current missions. And my project represents a promising life detection method for the near future using existing mission capabilities. Thank you.
Thank you.